This is a recording of the IRSA workshop given at ExSoCal in September 2016. So the bottom line of this brief talk is that IRSA has many different data sets and tools that may be of interest to exoplanet researchers. We have observations of stars and planets, local and exoplanets, from Spitzer, from NEOWISE. You can look for planets in our solar system that were accidentally observed, usually like asteroids that were accidentally observed, using our pre-covery tool. You can also use our resources for planning observations, primarily a tool called FinderChart. We're also the home for the PTF, the Palomar Transient Factory, and some related projects, and we'll be hosting IRTF and SOFIA data here at IRSA in the future as well. So what is IRSA? IRSA is the Infrared Science Archive. It is NASA's home for infrared and submillimeter data and tools. We enable cutting-edge research because we have multiple high-quality, both space and ground-based data sets, and we have lots of data analysis and visualization tools. It turns out that at least 10% of all refereed astronomy journal articles use, at least in part, data that came from IRSA. So we have petabytes of images, we have billions of rows and catalogs, and they're growing all the time. We're active mission archives for Spitzer and NEOWISE. We're working on preparing for new missions, possibly NeoCam. We're working with new versions of existing data delivered back to us by the projects or by individuals in the community. And because we're able to do that, we can enable science, even science that hadn't been thought of at the time, with the tools that we have, the virtual observatory, VO support, user support, and because we have many different data sets over many different wavelengths over the whole sky, and time domain data, we have a lot of resources at IRSA. This is what our homepage looks like. There's lots of different tools. I want to call your attention to the Help Desk button in the lower right. And if you're watching this video, you already know that we have video tutorials. The video tutorials are all stored on IRSA's YouTube channel. We have more than 50 videos there. We also have chosen to use the playlists as sort of tables of contents to group together videos on a theme. So if you go to the Playlists tab, you can get access to all the playlists in this feed. So for example, you can have just the videos that pertain to WISE and solar system objects, or just the videos having to do with the Spitzer Heritage Archive are all collected there. Many videos appear in more than one playlist. So Spitzer, of course, is an 85 centimeter space-based infrared telescope in Earth trailing orbit. It will be ending in 2019. It is a pointed mission, which means that it's used to cover specific areas of sky as opposed to a survey mission. There are, of course, many different significant exoplanet programs that are part of the Spitzer archive. Through the Spitzer Heritage Archive, you can search for the original data obtained by these projects. You can also look for delivered data products, including time series data. You can look for observations that were deliberately planned of solar system objects, in other words, tracking on Neptune, for example, or you can look for serendipitous observations of solar system objects, in other words, observations that happened to catch an asteroid in the frame. So the Spitzer Heritage Archive looks like this. Since many of IRSA's tools have the same look and feel, let me spend a few minutes talking about the layout here. In the upper left, we got the Searches tab. That's where we are. If you log in, or even just within your session, it keeps track of the search history you've done, and you can obtain that here. You can read in your own FITS file on which you can overlay catalogs, for example. You can set preferences, or you can get access to help, either through this tab or by clicking on any of the little circled question marks located throughout the archive. There's many different searches you can do. You can just do a position search, but you can also specifically search for moving objects, in other words, tracking on the object, or you can look for the pre-covery observations, which are the serendipitous observations. You also can, of course, search by observer or program, or the abstract text. So for example, if you specifically did want to get time series observations of Neptune, you would search on moving object, you would put in the name of the target here, and it gets for you the NAIF ID there. This is, of course, the target of the observation. They're not serendipitous observations of Neptune, but targeted observations. And you can tell it what products you want. So here it gets several different observations of Neptune. Almost all of them here are IRS observations, spectroscopy observations, but there's additional observations. If you scroll down, there's additional observations with imaging observations as well. You can, of course, search by observer. So if you want to get, say, for example, all of the observations Drake Deming has been a part of, you can do that. And here's all of the observations associated with his name. You can also search, like I mentioned, these pre-covery observations. In other words, did this object happen to be observed in the process of doing other observations? This otherwise nondescript asteroid is in fact observed in these individual frames in Spitzer. I'm going to add arrows so that you can see them more easily. But there they all are. There are all the observations of this particular rock. Now, these observations were not targeted at this rock. They just happened to catch this rock. So WISE is the Wide Field Infrared Survey Explorer. It's only a 40 centimeter space-based IR telescope. It was a survey mission, so it surveyed the whole sky within 4 bands between 3 and 22 microns. It produces both images and catalogs, and there are several different data releases, and they have slightly different uses. And there's also something called the Moving Target Coadder. So the different releases do matter. You can get basically two clumps of WISE deliveries. You can get atlas images, in other words, summed up individual frames, and you can get photometry from those summed up frames, or you can look at the individual exposures and the photometry derived from those exposures. So to first order look, if your targets don't move from night to night, you want the summed up images. If your targets do move, you want the individual exposures and the photometry that goes with them. But you're probably wondering now, why am I telling you this? See, it does matter. And in order for you to request the data that you need, you kind of have to understand these different kind of deliveries. And this is why. So if you go to the search page for WISE, you can search by position like, all these other IRSA tools. But look, even when you're searching by position, even when you're searching by solar system object, you still have to tell it what delivery of images you want it to search. So this graphic attempts to explain why there's so many different deliveries. So the 4 bands here are representations of the 4 bands that WISE observed in: 3.5, 4.5, 12, and 22 microns. So all 4 bands, the spacecraft was launched in late 2009, and it went into nominal operations in January 2010. It finished the first 6 months pass on the sky, in other words, did the whole sky 6 months later by July 2010. But by August 2010, we started to run out of cryogen, and we lost the longest wavelength channel from WISE first. About 6 weeks later, we lost the 12 micron channel. Now, even though it's run out of cryo, it can still observe in the shortest 2 channels, which it happily did until we ran out of money in February 2011. So at the time, this is what we thought we were going to get. So WISE All Sky was when all 4 bands were operating. Then there was 6 weeks of data when there were just 3 bands operating. And then there was a sort of tail end with the only 2 band observations. And at the time, like I said, this is what we thought was all we were going to get. So all of that together is represented by all WISE. And the spacecraft was put into hibernation. But then we got money and we woke it up again. So in 2014 started technically in December 2013, we woke up the spacecraft, got it cooled down again, and started another year of observations. So between December 2013 and December 2014, that's the first year of NEOWISE. Then 2014 December through 2015 December is the second year, and then 2015 December through 2016 December is the third year. And so you see we have lots of additional sky coverage in those 2 bands. So what you're going to use depends on what you need it for. And the all WISE data release is not, in fact, all of the WISE data. It's all the WISE data we had at the time. But there's lots of additional data obtained since then. So when you go to select the data releases, you can choose the preliminary release data. Do this only if you know what you're doing. Otherwise, don't even bother. For the All Sky release, remember the All Sky is just the 4 band data. The 3 band release is just the 6 weeks where we had only 3 bands. The post cryo 2 band is that first chunk of 2 bands only. Then all WISE is all of the WISE data prior to hibernation, all summed up. The NEOWISE stuff is the newest releases. That's the reactivated NEOWISE. That's 2-band data. Currently, you can get the first and second year. The third year is coming. So the data products that go with these different releases vary. Here's all the data releases listed here. If you want the summed up co-added images, those are the releases, the All-Sky 3-man cryo and always. And the photometry goes with that. You can also get the individual exposures or the photometry from the exposures. Again, use this if your targets have the same right ascension and declination from night to night. Use these if your targets are moving. So if you're still at the point of, oh my God, just give me the data, search in the WISE image service, because you can search all the deliveries at once. You should ask it for images from every delivery. And if you have a target with fixed right ascension and declination, just use the all WISE release. That'll probably get you where you want to go. If you have a moving target, you need to use the WISE image service to identify which delivery contains your object, and then go and get the catalogs that go with it. So this is what searching in the WISE image service for this particular rock looks like. This is a Kobe image. That's the ecliptic plane. You can see there's 4 different sets of observations of this particular rock. And here's all the individual exposures. The box in the center is where the object is in that frame. There are X's where the object is in the other frames. So if you want to go and grab the catalogs, you go up to the catalogs tab and you can search the individual exposures photometry. But if you have an object that was known at the time of processing, you can look in the known solar system object possible association list. You should click on and read that caution. But say you're interested in what Neptune is doing as a function of time, then you want that known solar system object possible association list. You can also search in the catalog search tool directly. You can choose the WISE catalog and scroll down until you find the known solar system object possible association list, and then search on that and tell it I want all instances of Neptune, and then it'll give it to you. So that's a Neptune light curve on the right here. Brightness is a function of time. It found 2 apparitions in this particular delivery, and there's the individual frames. So overall, if you want images, use the WISE image service. Trust me, you want the images. Then you can overlay the catalogs on the images there. If you are sure you just want catalogs, you can go to the catalog search, or you can do it from the WISE image service. If your target is not moving, use all WISE or all sky. If you have moving targets, you can use all the other releases. If you have something that's too faint for all WISE, and it's important to you to add in the more recent data, you want to use the WISE NEOWISE co-adder. It was originally developed in the context of NEOWISE. What it does is it lines up frames and adds them up. You can either stack them up in a moving frame or stack them up by right ascension and declination. You can just give it a list of frames, or you can give it a solar system object. So you can sum up all data of a given target over the entire WISE mission, and that's going to make a big difference for the first two channels of WISE. You can co-add images of a moving target. You put in your ephemeris, and it goes and gets the target and lines it up on the moving object. You can also identify, say, a category of object at a wide variety of RA index, say maybe white dwarfs that have a WISE 2 measurement but no WISE 1. So go get all the objects in your category, stack them up, and then you can dig out an average WISE 1 brightness, for example. This is what it looks like. You can put in the coordinates, you can put in a moving object, and you can put in the parameters that you want to add it up. We're also the home of PTF, the Palomar Transient Factory. IPTF is the intermediate PTF, and ZTF, which is coming soon, is the Zwicky Transient Facility. It's using the 48-inch at Palomar. It does a large field imaging survey. They're specifically looking for extragalactic transients, but of course we get light curves for free from those data. They've just had a recent big data release. There's going to be a lot more to come, and for those of you who study the rocks in our solar system, when they find a moving object, they report it. And the PTF search looks a lot like all the other searches. You put in your position and the search region that you want, and you get back a list of the observations and the image on the right-hand side. We're developing a light curve viewer. This is going to develop anything that is any data that are as a function of time at IRSA. So WISE data, Spitzer data, PTF data, anything. It's still very much an active development, and the thing that we're developing at IRSA is going to work closely with the NEXI periodogram service to do calculations and display the results. It also has a similar look and feel as many of the other tools I've shown you. This light curve viewer version is so early. It's pre-alpha. I don't even see it on my computer. This is from the developer's computer. Here in the upper left, we have the input parameters. We have the individual epochs and the photometry on the lower right, the light curve plot on the top, and then the individual frame here. So as you scroll through the list, it's highlighted in the light curve, and you pull up the individual frame here on the right-hand side. So the FinderChart tool, this underwent a complete redesign in 2012. If you haven't been recently, you should come check it out. For reasons passing understanding, if you Google IRSA FinderChart, Google drops you in the old tool. We don't understand why, but there is a link there that takes you to the new tool. It gives you simultaneous access to 2MAS WISE and IRAS, as well as the Palomar DSS and Sloan Digital Sky Survey, and both the images and the catalogs from these surveys. Because they are surveys, they're not individual exposures, so they're good if you're studying moving objects for where your object is or was or is going to be for an upcoming observation. It will give you images up to a degree, and the ExSoFop tool at NEXI uses this FinderChart service. This is what it looks like. It looks a lot like the other IRSA tools I've shown you. You can put in a position, you can tell it how big you want, and you can tell it the individual surveys that you want, and whether or not you want it to search the corresponding catalog within the entire image boundary or within just a search radius. You can also tell it, just give me the closest source to the position that you've given it. So this is the same galaxy at many different wavelengths. We've got the DSS at the top, and you can ask it to make a 3-color image. You can change what planes it picks, but it's picked a default collection for the RGB colors here. There's a Sloan image and the Sloan 3-color 2MAS. The tiles are small. I know we're working on it, but there's the 2MAS 3-color image. There's the WISE and the WISE 3-color image, and even IRAS with an IRAS 3-color image. So you can, if you've asked it to give you the catalog, it can be overwhelming. DSS, of course, doesn't have a catalog that goes with it, but 2MAS does. That's a 2MAS image and the 2MAS catalog on top of it, and then the WISE image and the WISE catalog on top of it. And these are linked. You can scroll through the catalog and pick out individual sources or click in the sources and see which catalog row it corresponds to. But you can also filter. So here I've filtered it so that only the brightest sources are overlaid. So I put in a filter of signal to noise ratio greater than 10 in all 4 bands, and so I've only given it only 181 sources. Sorry, only 9,000 sources are remaining over 881 pages, and over the field of view that I've got marked here is just a handful of sources. But you can also use it for observation planning. You can overlay a wide variety of footprints from HST, JWST, WFIRST, and Spitzer. This one happens to be a MIRI field of view overlaid on WASP 12. And then as preview of coming attractions, the IRTF data are going to be archived at IRSA. We're going to start with SPECS and iShell as the first data set. The data that are being taken right now go public next fall, and that's going to be the inaugural data sets in this archive. And there's going to be more instruments added in 2018. There are going to be some tools as part of that archive specifically for solar system object data. And the SOFIA archive will also be here at IRSA. The calendar is being worked out, but we will be the home for both public and proprietary SOFIA data. So just to reiterate, we've got lots of different data sets of interest to exoplanet observers. We've got observations of a wide variety of objects taken with Spitzer and NEOWISE. You can use the pre-covery tool to recover observations, serendipitous observations of moving objects. You can use our resources such as FinderChart for planning observations. And we will be hosting IRTF and SOFIA data at IRSA as well.